it later also, right? And at the same time I will be providing some content also, and you visit that site where you will get all our content, necessary content. Okay, so so what we were talking about yesterday, uh, we discuss about books, we discuss about exam pattern. Our exam will be 15 plus 35, 15 marks for internal, 35 marks for external exam, final exam. Same is the pattern from both of the mathematics paper and all subjects, right? So for practical, we'll have 6 plus 12 ideally practicals there, and we may have many practicals. Okay, so we were talking about we'll spend few lectures on mathematical thinking. What is the way of thinking in mathematics, right? Because this is not like your 11 12 standard mathematics. You have to think from basics, and it will be more logical than computational, right? So we have to develop your logical ability so that you will feel better while learning this mathematics and especially calculus. So uh, we'll spend few lectures on uh, uh, mathematical logic and thinking and methods of proof. How do we think when we'll solve some problem, and what should be the strategy or what should be our mindset while solving some problems in mathematics. Remember that in mathematics, in BSc mathematics or FY BSc calculus, each problem is of different type, has different type, and it will not happen that we will solve 20 problems of type 1 and 30 problems of type 2 and 10 problems of type 3 and so on. This will not be the case. Once problem is in front of you, you have to think from basic, and you have to apply basic definitions and basic results. That will be the strategy, right? So okay, so we were talking about this example, De Morgan's laws, and how will you prove the De Morgan's laws, right? So what De Morgan's law says, if you have two sets A and B, and we are interested in A union B complement, and what De Morgan's law says, A complement intersection B complement. So uh, what we need to prove is basically here, what we want to prove is we want to prove that two sets are equal. When you want to prove the De Morgan's laws, right? So when we want to prove De Morgan's laws, we want to prove that these two sets are equal. Second is A intersection B complement is equal to A complement union B complement. Okay, so uh, how will you prove this, right? How will you prove this? And last time we discussed that what is the important point while proving this? If you have two sets x and y, right? If x and y are two sets, uh, if x and y are two sets, then when we say that two sets are equal, x is equal to y if and only if they are subsets of each other and y is subset of x, right? Subset means what? Subset or equal, they are, yeah, equal or they are subsets of each other. That is what it means anyway. So when two sets are equal, if they are subsets of each other. Now in De Morgan's law, what we need to prove is this is equal to this. So what is the left hand side of this? Left hand side itself is some set, and right hand side is again a set, right? And we want to prove this law means what? If you want to prove first and second, so if you want to prove first, that means you want to prove two sets are equal. Left hand side is some set and right hand side is another set. And in any situation, in any general situation, whatever your set is, in any situation, how to prove this? Let us, I will prove first, and then similarly you can try for second, right? So what is my claim? What is my claim? uh, A union B complement is equal to A complement intersection B complement. So this is my claim. So to prove this, we need to prove that. So what is our previous knowledge, right? What is our previous knowledge? So this is our previous knowledge. Is it clear? Right? So two sets are equal if and only if they are subsets of each other. This is our previous knowledge. And now we want to prove De Morgan's law. Means we want to prove these two things are equal. That means one side is a set, another side is also set. That means we ultimately we want to prove that two sets are equal. And therefore to prove this, we need to prove that. What we need to prove? Is it clear? Is it clear what I want to say?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
We need, we need to prove that A union B complement is subset of A
Subset of.
complement intersection B complement, and A union B, its complement is subset, is superset, or I can say subset. So A union B, its complement is superset of, or A complement intersection B complement is subset of A union B complement, right? So let us prove first. If you are able to prove first, then check whether you are able to prove second. If you are able to prove both, then we are done. Then we can declare that these two sets are, this set and this set are subsets of each other, and therefore by this logic or this previous knowledge, we can say that these two are equal, right? That is what the simple strategy. Okay, so first, let us prove first part. How will you prove that this is a subset? So then what is our previous knowledge? Okay, let me see why I am telling this, because I am telling this because what should be the way of thinking while doing mathematics, right? But every time will not be going such slowly, because we have to do lots of things in calculus. So if you go such slowly, then we cannot do all these things, right? So since this is the initial stage, I am going slowly, but anyway, this is a way how we should think. So what is our previous knowledge? Our previous knowledge is set X is subset of set Y if, when we say that some set is subset of another set, if for each X in X, X is member of Y. Is it clear? For example,
Yes.
if you think about real life situation, if my set is students in the college, all students in the college, right? And what is my set X? All students from FY E division, right? This is my these are my sets. Fine. Okay, so can I say that X is subset of Y, right?
Yes, sir.
So
Yes, sir.
clearly X is subset of Y, because or if you choose any student from E division, ultimately he is a member of college, right? So if you choose any member from X, that means if you choose any member from division E, so ultimately you will be a member of Y, and that is what mathematically X is subset of Y if and only if every member of X is again a member of Y, right? So for each X in X, we have, or I should say more precisely, we have X is member of Y. You choose, so you have set X and you have set Y. When we believe that ki X is a subset of Y, close your eyes and choose arbitrary element from X and open your eyes, you can see that it is member of Y. Right, no bias, without any bias. If you choose arbitrary element, and it should happen that, right, without any bias, if you choose a arbitrary member of X, it should happen that it is also member of Y. Then clearly, no matter which element you select, ultimately entire set X sits inside set Y, right? That is what logically we need to understand. Okay, so this is our previous knowledge. So from this previous knowledge, we want to prove this कि A union B complement is subset of A complement intersection B complement. So what is our first part? So A union B complement is subset of A complement intersection B complement. This we need to prove. Okay, so how to prove this? Right? So we want to prove that some set is a subset of another set. That is what is our aim. And ultimately by our this note, second note, what we should do. So what I should do while proving this, what I should do logically, right? Think logically means naturally. Naturally, what should be what should be our strategy? Don't think about any formula, any previous method which your teacher in 12th standard or 11th standard told you. Don't try to remember those methods. Just think naturally. Naturally, what comes in your mind?
And can I see, sir? Hello.
So choose arbitrary element from A union B complement. So let X from A union B its complement. I have selected arbitrary element. I just close my eyes and I just selected arbitrary element from A union B complement, and then I am going to open my eyes and then I want to see check whether that element also lies in A complement intersection B complement, right? Is it fine? Okay. Then if I have selected element from A union B complement, that means X is not member of A union B. Is it true? This
Yes, sir.
implies
Yes,
X is not member of A union B. X is neither in A and X is nor in B. Is it true? If some member is not in some element
yes,
is not in union, then
Yes,
it
sir.
is neither in A nor in B. Otherwise, if it is in one of them, it will be in union. But that is not actually happening, so it is not in both of them. So X is neither in A.
Your screen is not visible.
So please keep your mic off. It create noise. Okay, so X is neither in A, X nor in B. This implies X is not in A means what? X is in
X is in
A
A
complement
complement.
and X is in B complement. But X is in both of them, A complement and B complement. That means X is in their intersection. X is in A complement intersection B complement. Right. So hence what we proved, if you select arbitrary element from A union B complement, then we close our eyes and we selected arbitrary element from A union B complement, and now we open our eyes and we see that A complement X lies in A complement intersection B complement. Right, this hold for every element. Right, this hold for every element of A union B complement. Is it true? Is it special about particular element?
No, sir.
Right? It holds for any because I selected arbitrary, no bias. I just close my eyes and select, and then I found that it is in A complement intersection B complement. And what is the conclusion? Thus, can I write final conclusion? Thus, entire set A union B complement is inside A complement intersection B complement. This conclusion I can make immediately if it is if this hold for any element, every element of A union B complement, right? And thus the half part is done, right? This part is done. What is the remaining half part? This half part. So what is second half part? Next, want to prove. Right, so next, what is our aim? Other way round. What is other way round? A complement intersection B complement is subset of A union B complement, right? So this is the other way round. Okay, so what is the logic? Same logic. So choose arbitrary element from left hand side and open your eyes and see that it is here also, and that's done. Okay, so let I just close my eyes and select arbitrary element from left side set, right? Then what process is going on in my mind? If I select X from A complement intersection B complement, then X is in A complement as well as X is in B complement. It is in both complements, right? So, but then, so that, but X is in A complement, that means X is not in A, right? At the same time, X is not in B, right? But if X is neither in A nor in B, that means X is not in their union, right? If some element is in the union, then definitely it must be in one of them. But what is our previous step says ki it is neither in A nor in B, then certainly it is not in union. And if some element is not in A union B, or some element is not in this set, then that element is in its complement. It must be in its complement, A union B complements. So hence, what is the conclusion? If I select any element from A complement intersection B complement, then I came to conclusion that that element is in A union B, its complement, right? And this is true for arbitrary element, no special element. Arbitrary element, every element satisfies this. Therefore, entire set A complement intersection B complement sits inside A union B its complement, right? And therefore, what is the final conclusion? Thus, therefore, from 1 and 2, what is our conclusion? So what one says ki A union B complement is subset of A complement intersection B complement, and what second says A complement intersection B complement is subset of A union B complement. So they are subsets of each other. We have A union B complement is same as A complement intersection B complement. Right. So is it done now? Is it done?
Yes, sir.
Yes.
Okay.
Yes, sir.
And
Yes, sir.
now this proof is not special about any particular sets. This is a general proof. Now you go anywhere, any time in the world, the same proof works, right? Because A and B are not special sets at all. You choose any two sets, these things holds to be true, right? Similarly, proof second is second De Morgan's law. What is a second De Morgan's law? A intersection B complement is equal to A complement union B complement. So you now try to prove this. This is not very difficult at all. You just note it down and prove it as a homework, right? So this is homework. You try to prove this. Okay, now now my next example is let A, B, C be three sets. Suppose we have three sets. Now, what I expect, does De Morgan's law hold for three sets? What is your answer? Have you tried for three sets?
Yes.
Is it true for three sets?
Yes. Hello.
Yes. Does it hold for three sets? Then A union B union C, its complement is equal to A
Yes, it is.
complement intersection B complement intersection C complement, and A intersection B intersection C complement is equal to A complement union B complement union C complement, right? Now it is not very difficult to prove this. You can actually prove. So you try to prove this by same logic. So this is exercise homework. You try to prove this. Now I want to make problem more general, right? So suppose I have 100 sets, right? Okay, please keep your mic off. If you are not talking with me, then keep mic off. Anyway, so if you have 100 sets or thousands of sets, and I want to take, so let A1, A2, A3, A100. I have 100 sets, right? B sets. So I have these many sets, and so my question is, does laws hold for A1, A2, A100? Right. So does De Morgan's laws hold for 100 sets? Okay. Uh, by previous technique, suppose you prove for 100 set because 100 is a small number. Is it true for 1000 sets? Right. Again, our question come in our mind: is it true for 1000 sets? Is it true for 5000 sets? And then is it true for 1 lakh sets? So uh, but it is not convenient to check for 1000 sets or 5000 sets, right? And so we should have some general strategy, right? Once you prove that general strategy, then we can simplify our process of proving such kind of things, right? And what is that natural strategy or technique, right? That technique is called as mathematical induction. Right, so mathematical induction, and most of you have already studied mathematical induction in 11th or 12th standard, or some people might not have seen. So let me explain this. What is a mathematical induction? So before going to mathematical induction, first of all note something. Inductive properties. Before going to inductive properties, let me say few words about natural numbers. Right. So, what are natural numbers? Natural numbers are counting numbers. Right. So, natural numbers.
Sir, is this under inductive properties?
Uh, yeah, I am talking about going to talk about mathematical induction, but before going to inductive properties, let me make something clear about natural numbers, right? So, what are natural numbers? Natural numbers are counting numbers. Right. So, the numbers which we generally use for counting. And so mathematician Kronecker said that the natural numbers are God given. Right. God given in the sense the technique of counting. See, let me tell you some history about natural numbers. So, see what is my ultimate aim? How to prove this kind of thing? How De Morgan's law hold for 100 sets or 1000 sets? And that is my main aim. But I need some machineries. I need some tools, and that tool is one of the tool is mathematical induction. But to understand mathematical induction, I should go some in deeper uh, thing, that is what are the natural numbers and what is the meaning of induction or inductive properties. Induction is same as inductive properties. So what are natural numbers? So counting numbers. So ancient people were using natural numbers for counting, but they did not know the symbols like 1 2 3 and so on, right? 1 2 3 4 and so on. These are natural numbers we are using currently, and people just using sticks or stones, they had kettles or sheeps or whatever their things or personal belongings, they use such kind of things, sticks or paintings on wall. They they used to have paintings or lines on the walls like these many kettles or these many kettles or these many sheeps or these many things, right? They were using some such kind of things for counting. But later on, people as mathematics developed, people use special symbols. Let us use this symbol for these many kettles, right? Let us use this symbol for these many kettles. Let us use these many symbols for this. These are 4 kettles. Then, or these are five things, personal things. Then they use this symbol. So these are symbols for our understanding, for our convenience. These symbols are not special at all, but these symbols are universally accepted, and for our day-to-day life communication we are using these symbols. That's why now we have accepted these symbols. Otherwise, if ancient people or mathematicians would have given some different symbol, then the we will be using some those symbols, right? But though ancient people thought that these are convenient symbols and these will be easy, these symbols would be easy for communication. Then uh, entire world accepted these symbols, and now we are using these symbols. Otherwise, these are just symbols for representing how many things, one things, two things, three things, four things, and so on. Okay, so these are natural numbers. And then
Excuse me,
people
sir.
thought about, yes.
Sir, Roman numbers were also used in those days, what?
Yes, that was a kind of thinking, what they felt convenient. because they thought that how many lines we can make to count. Then they found that it is difficult, 6 7 lines it was difficult. Then they found some smart way ki, okay, let us denote this by something like this, so that is smaller. Let us denote this by this, so that it will reduce your space, and it will be convenient, right? That was whatever was in their mind, that is the history, right? But and then what is the special about natural numbers and set theoretic notation? In set theoretic notation, okay, let me tell you book. Everyone should try to read this book. The name of book is NAIVE, naive set theory. Those who want to do mathematics seriously, right? By Paul Holmos. So this is a very good book, and this book gives the deep knowledge of set theory, logic, how the entire structure of mathematics or sets is developed, right? So far whatever you have studied, that was just a simple thing, like many people know how to drive the car, right? For example, driver, and driver, most of the time drivers are not engineers, right? Drivers are just graduates or 10th pass or 12th pass, but they can drive car nicely, right? But they do not know how this machine is constructed, how machine is designed, how it consumes fuel, or how much pollution it creates. He's not bothered about it. So same thing happened till date. When you passed 12th standard, you were just using machineries. You knew the techniques, but you did not know how these techniques are constructed, how car is built, how car is constructed, what are its parameters, how it is designed. So if you look at the car, how it is designed, so that the minimum air resistance is there, and so fuel efficiency is increased. And engineers are thinking about it, and they have some calculation, they have some softwares, they have some logic, they are using some mathematics, they are using some physics, they are using chemistry also, right? So that is what is behind it. So to become a good science student, I am not saying a scientist. Certainly you will become a scientist if you think in this way. To become, initially you should think about a good science students, and to become a good science students you should read such kind of books. One of the book that I told you is Bartle and Sherwood, Introduction to Real Analysis, and this is another book. It is not directly for our syllabus, but you should read this book simultaneously, Naive Set Theory by Paul Holmos, and then you will understand how this set theoretic things are developed, and what is a way of thinking, and what is a deep thinking in set theory, and about sets and all these things,
Excuse me,
natural
sir.
numbers.
Sir, I was saying that yesterday you gave a reference book name,
Yeah.
which Robert R. Bartle something.
Uh,
Sir, that books have two copies. Like one costs 11,000 and something,
uh.
and one costs 400.
We are not interested in cost. We are interested in book, right? And most of the books like Springer or foreign publishers, they have two types of copies. One is Indian edition, another is non-Asian, basically Asian edition. In Asian countries, they uh, economy edition means they have low price editions, right? Like Sri Lanka, India, Pakistan, or other countries, Asian countries, they have low price editions. So Indian editions are cheaper, means 400, 500. And if you try to find same book for the international editions, but content is same, no change in the content. right? For developing countries, some publishers have these kind of schemes, so that is happening. But we are interested in content, so we are not interested in cost,
Excuse
right?
me, sir.
Yes.
So yesterday I shared the book Introduction to Reanalysis
Yeah,
on the
that is
WhatsApp group.
correct. That is
That
the
was
correct. That is same copy, right?
okay. Okay. So we can refer that book, no?
Yeah, no doubt. And you should read that book from first page, as I told you, because if you
Yeah,
start reading any
preface only.
book, try to read from first page, and try to read from first chapter itself. As far as calculus is concerned, our syllabus starts from second chapter, and first chapter is in algebra. Some part of first chapter is in algebra, but anyway, you should read from first chapter and try to solve all the problems, exercises in that book. You make a notebook and try to solve. Initially, you may find it difficult, but certainly after some days, if you keep it on reading, then you will be at comfortable level, and you will be very happy. You can understand at least some mathematics, no matter how many marks you got in 12th standard.
Excuse me,
Even
sir.
you got 100. Yes, yes,
Sir, there are two books we have shared yesterday. So one is having some different kind of edition. Means the first chapter is about preliminaries, and the other book is having starting from a set relation and function type of
yeah.
something.
So, as I told you, ki Bartle and Sherbert book is for our right. So start reading Bartle and Sherbert. The second book is a book by S. Kumaresan. Let me tell you something about S. Kumaresan. S. Kumaresan was is a mathematician. He was professor in Mumbai University, and then he became professor in Hyderabad Central University, and he is working since last 25 years for undergraduate students, and he have written lots of literature in mathematics for undergraduate students. And you just search on Google S. Kumresan online notes, right? So what you should search, S. Kumresan. So or soft copies. Online notes means he have made the whatever he has written online on MTTS website. MTTS website. Go to MTTS website. What is MTTS? Mathematics Training and Talent Search. And let me tell you one more thing about MTTS. Every year in the summer, MTTS organize workshop for undergraduate students, and FYBSc students can apply for zero level, right? FYSY students can apply for zero level. TYBSc student can apply level 1, right? So in this year also you can apply for zero level, and that is a very good experience to learn mathematics, because whatever is being taught at MTTS workshop, it is very fantastic mathematics. What is they develop your thinking power, and many people, uh, this is my experience, many people came, joined Ferguson to do physics or other things, and then decided to do mathematics, because they got interest in mathematics, because they understood the beauty of mathematics, right? And I am not saying that you should do mathematics or you should do this subject. You don't decide any subject right now. You read good books in that subject, and then think whether it is appealing to you, where it creates interest. If it creates you to interest and you feel that it is my cup of tea, then you choose that subject, right? I will not say you do mathematics right now, so you do whatever you like, but you read in the beginning you should try to read good books in that subject, and one of the good book is Bartle Sherbert book, that everyone should read. And one of, I told, the second book, Naive Set Theory by Paul Halmos. Okay, so the point is, S. Kumaresan has written lots of things for mathematics, and the way he has written is the from natural way. Natural way means what? Ki without any big knowledge or big result or big formulae, how to think, how to solve particular problems in mathematics, right? So whatever machineries, whatever tools you have, for example, if you want to cut something, and you don't need big cutter, right? If you can cut it by a small cutter, then that's fine. And then why to waste our energy, and why to waste our money, and why to waste our time? So if you think logically, naturally, and in less amount of efforts, so that is a way of natural thinking. And in calculus, I will give more emphasis on natural thinking. See how to think naturally. Don't think about previous known formulas or known methods. So just think what you learned currently, and then apply that knowledge to solve particular things. So the another second book that I told yesterday was written by S. Kumresan and Ajit Kumar. These two people are working for undergraduate students, and they have written lots of things, material for undergraduate students. Okay, this is something about MTTS, and many programs are going at ICERs, IISCs, right? ICERs, uh, IITs, and IISCs.
Sir, could you repeat
Right.
once again, please? Your voice
MTTS
was
organize MTTS organize workshop in summer every year. They put a notice on website, so you just
okay.
refer and then apply, and then for that you need recommendations from your teachers, right? If you are
Okay.
applying for
Yes.
mathematics MTTS, then you should have good rapport with your teacher, so that teacher can recommend you. If you are not uh, uh, interacting with teachers, and teacher don't know anything about your knowledge, teacher cannot recommend you. Or if your knowledge is not good, teacher will say that I teacher will give you grades. So it is asked to give grades 1, 2, 3 up to 10, and according to your understanding, according to your efforts, according to your sincerity, teacher gives you recommendations, and on base of recommendation you will be selected at various things, right? ICER
Okay.
organizes various workshops. There are many ICERs in India. In Pune, ICER is there, so they are organize many workshops in summer, winter, 1 month workshops, and they call for applications. And then also you need recommendation. IITs also organize such kind of thing. IISCs, Indian Institute of Science, Bangalore, Kolkata, they organize such things. So you should keep your eyes open for such kind of things, right? Okay, so this is something about your planning. Anyway, so mm, okay, so I told you this about book. Anyway, we were talking about natural numbers. So natural numbers are counting numbers. And what is the speciality of natural numbers? So inductive properties.
Excuse me, sir.
Oh, yes,
A natural number is an integer greater than zero.
yes,
Yeah, it is starting from 1 to
yes.
the infinity.
Huh, right. But I will tell you history about that also, because natural numbers, the set of natural numbers is denoted by this special symbol, right? Let me draw it properly, so that otherwise you will say that you wrote in this way, so that in exam I am writing in this way. So uh, natural numbers are denoted by this symbol, this special symbol for natural numbers. So inductive property. So what she said just now, initially there were people knew only natural numbers. But later on, people felt that these numbers are not sufficient, so we should include many more numbers due to need of time, due to real life problems, and then people included negative of natural numbers, right, -1, -2. But then people felt that it is incomplete, then they included 0 and so on. So that was the history, and then in that set becomes set of integers, but initially they were natural numbers. So I think it is 2 o'clock, and next you have next lecture. So what exercise I gave you, the second part of De Morgan's law, and try to prove it for 3 sets. And then our aim is now for any number of sets, 100 sets or 1000 sets, is it true? And this is our aim, but how to prove it? Because proving for 100 sets is not sufficient. What about 1000 sets? Proving for 1000 sets is not sufficient. What about 2000 sets, right? And this process will not end. And therefore we should have some general strategy, because as a mathematics we should have a power, that a logic in one shot we should tackle all the cases, right? And that is what the mathematics power we want to develop. And to develop that power, I am talking about in mathematical induction. For that I need to think about natural numbers, and to understand natural numbers I need to understand some properties of natural numbers, so inductive property. Right, so this we'll discuss next time, right? Anybody want to ask doubts? Okay, so I want to ask whether this method is correct. I am writing on board and you can see my board. So are you comfortable with this method?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
So
Otherwise I can present type content and I can read. That is not the live experience. So I think this is better. So okay, thank you. We'll meet next time.
excuse me,
And
sir.
you have
Okay.
next. Yes.
This is to remind you that you should download attendance.
Yeah. Uh, I have already initially downloaded, but I will download it again, so that the people who join later will be, their attendance will be counted. So I am downloading it again. Okay, thank you. Okay, so
Thank you,
we'll
sir.
see next time. Okay, next
Thank
time
you,
we'll
sir.
Okay,
meet
thank you,
again.
sir.
Thank you, sir.
Thank you,
So
sir.
I
Bye,
am
everyone.
recording. Yeah.
Thank you, sir.